It often feels like there's a hidden set of rules running the world, connecting things in ways that are, well, predictable. Turns out there is. And today, we're going to pull back the curtain on one of the most powerful ideas in all of math and science, something called a function. Let's get into it.
So to get our heads around this hidden rule, we're not going to start with some crazy formula. Nope. We're going to start with a really practical problem, a simple question of cost.
Okay, picture this. You're moving, you need to rent a truck. You've got two options, Plan A and Plan B. One has a lower weekly fee, but it costs you more for every mile you drive. The other one's got a higher fee up front, but it's cheaper per mile. So, how in the world do you figure out which one is actually going to save you money?
And this graph, it lays out our problem perfectly. Each line represents the total cost for one of the companies. You can see one starts out cheaper, but its price climbs way faster. And right there, they cross. That's the break-even point. Before that point, one plan is better. After it, the other one is. So the real question is, how do we find that exact point? Well, to do that, we need a tool that can precisely describe this relationship between the miles we drive and the final cost.
And that tool, that's exactly what we're here to talk about. It's a concept that is, at its heart, beautifully simple. It's all about the input-output rule. The easiest way to wrap your head around a function is to think of it like a machine. You put something in, that's your input, and the machine follows a very specific rule and gives you something back. That's the output. So if you put in the number 5, maybe it always spits out 25. If you input 100 miles, it spits out a very specific rental cost. The absolute key here is consistency. A specific input always gives you the same predictable output.
And here it is, the official definition. Don't worry, it's not scary. A function is just a rule that assigns to each acceptable input value exactly one unique output value. That part right there, one unique output, that is the most important rule of the game. For any single input you give it, you will only ever get one answer back, period. So what happens if that rule gets broken? Okay, look on the left. We've got a perfect function. You put in an x of 2, and the only possible answer you can get for y is 5. Simple, clean. But now, check out the equation on the right. X plus y squared equals 1. If we put in an x value of 0, what can y be? Well, y could be 1, right? Because 1 squared is 1. But wait, y could also be negative 1, because negative 1 squared is also 1. Uh-oh, one input just gave us two different outputs. That breaks our main rule, so that relationship is not a function.
Okay, so that's the mathy part. But what if you just want to look at a graph and know instantly if it's a function or not? Well, for that, we have this awesome visual shortcut. It's like a little litmus test for graphs. It's called the vertical line test, and it is incredibly simple. You take any graph, like this parabola. If you can imagine drawing a vertical line anywhere on it, just slide a pencil across the screen, and it only ever crosses the curve at one single point at a time, then it's a function. It's just a quick visual way of proving that for every x value, there's only one y value. But look at what happens here. If we draw a vertical line on this circle, boom, it hits the curve in two places. This graph fails the test. It's telling us, visually, that for one input x, you're getting two possible outputs for y. And as we just learned, that means it is definitely not a function. It's really that simple.
Okay, so we can spot them. But what are they actually for? This is where things get really cool. See, functions aren't just one thing. They're a whole toolkit for describing reality. Each type of function has a different shape that can model a different pattern in the world.
First up in our toolkit, we've got the quadratic function, f of x equals x squared. Its classic U shape, which we call a parabola, is perfect for modeling things that go up and then come back down, like the arc of a thrown ball. It can also model a company's profit, which might rise to a peak before falling off again. Next, let's grab the cubic function, f of x equals x cubed. It's got this distinctive S-curve. This shape is great for modeling more complex relationships, things that grow, maybe flatten out for a bit, and then start growing again. Think about the connection between wind speed and the power you get from a wind turbine. It doesn't just increase in a straight line, it's more complicated than that. And for our last tool today, let's look at the square root function, f of x equals square root of x. Check out its shape. It starts off shooting up really quickly, but then it starts to level off. This is the perfect model for anything with diminishing returns, like a plant's growth, right? It's super rapid at first, but slows as it gets bigger.
Or even how your skills improve quickly when you first learn something, and then progress gets just a little bit slower over time.
So let's zoom out and bring this all together. These are not just abstract squiggles on a page from math class. They are a fundamental way of seeing and interpreting the world all around us. Ultimately, this is the big takeaway. Functions are the language of relationships. They allow us to take messy, real-world information and find the hidden, predictable patterns inside. They let us model everything from the flight of a bird to, you guessed it, finding the exact break-even point for our truck rental. That's the tool we were looking for all along.
And this isn't some high-level theoretical thing. It is literally everywhere. As the source material puts it, the cost of postage is related to the weight of the item. Yep, that's a function. The value of an investment will depend upon the time elapsed. That's a function too. See? You've been using this logic your entire life, probably without ever putting a name to it.
So the next time you see a price change, or you track your progress on a project, or even just watch a ball fly through the air, I want you to ask yourself, what's the rule here? What's the input and what's the output? Because now you have the tool to see it. So, what hidden relationships govern